Well, in this lecture, I spread some light on the probability distribution functions, and this is the second part of my lectures. So, on probability distributions. Okay, so probability distribution is two types. Okay, one is discrete probability distribution, and another is continuous probability distribution. And in case of discrete probability distribution, there are four types of distributions. There are four types of distributions under the discrete probability distribution. And what are those? Uniform probability distribution, Bernoulli probability distribution, binomial probability distribution, and Poisson probability distribution. These four distributions are discrete probability distribution under the probability distribution theory. And there is another type, that is the continuous probability distribution under the probability distribution theory. And there are five types of continuous probability distribution. Okay, one is normal probability distribution, another is student's t distribution, chi-squared distribution, exponential distribution, and logistic distribution. In this lecture, I try to spread some light on the uniform probability distribution, Bernoulli probability distribution, and binomial probability distribution, and also the Poisson probability distribution. But in my next part, we will discuss about the continuous probability distribution. Okay. So now, what is the uniform probability distribution? In probability theory and statistics, the discrete uniform probability distribution is a systematic probability distribution. It is a systematic probability distribution. You must remember this. It is a systematic probability distribution, and wherein a finite number of values are equally likely to be observed. A finite number of values are equally likely to be observed. Every one of n values has equal probability, that is 1 by n. Every one of n values has equal probability, that is 1 by n. With an example, I can clarify it in very well. Okay. It is an example of throwing a fair die. The possible values are, if you throw a die, the possible values are 1, 2, 3, 4, 5, and 6. Okay? And each time the die is thrown, the probability of a given score is 1 by 6. Look, if you throw a die and probability of occurrence of particular event or particular outcome or particular score is 1 by 6. Probability of occurrence of 1 of the die is 1 by 6. Probability of occurrence of 2 of the die is 1 by 6. Probability of 3 is 1 by 6. Probability 4 is 1 by 6. In the same way, probability of 5 and probability of 6 are 1 by 6 and 1 by 6 respectively, or the same. Okay. So the probability theory and statistics, the discrete uniform probability distribution is a systematic probability distribution, and here a finite number of values are equally likely to be observed. Finite number of values. Okay. If you see the pictorial presentation, that is along the vertical axis we measure the probability of x, that is px, and along the horizontal axis we measure variable x. Okay, so 1 is a point, is a score on the die, and 2 is another point, another score, 3 is another score, 4 is another score, 5 is another score, 6 is another score. So if you see the line, then you can find all the lines are same. All the lines have the same probability, that is 1 by 6. 1 by 6. This is the uniform probability distribution, where a finite number of values are equally likely to be observed. That is here 1 by 6. Okay, so this is the uniform probability distribution. Now, Bernoulli probability distribution. What is the Bernoulli probability distribution? In probability theory and statistics, the Bernoulli distribution, named after Swiss mathematician Jacob Bernoulli. Jacob Bernoulli, as far as the Jacob Bernoulli's theory is concerned, this is the Bernoulli probability distribution. And it is a discrete probability distribution of a random variable, and which takes the value of 1 with probability p and the value 0 with probability q. Q is 1 minus p. The Bernoulli distribution is a special case of binomial distribution. You must remember this. The Bernoulli distribution is a special case of binomial distribution where a single trial is conducted. When the trial is n number, then it is the binomial distribution. When the value of n, the value of trial is 1, then it is Bernoulli distribution. Flipping a coin, if there is head, it means success, and if there is tail, then it is failure. So probability of success is 1 by 2 naturally. Probability of success is 1 by 2, and probability of failure 1 minus p. 1 minus p means 1 minus half is equal to half. So here mean is the 1 by half. Mean is 1 by half, and variance is p multiplied with 1 minus p. It is the probability of success multiplied with the probability of failure. Okay, so this is the Bernoulli probability distribution. Now, the binomial distribution. In any binomial experiment, each sequence of trial outcomes yielding X success in n trials has the same probability of occurrence. Binomial probability function can be written in this way. Okay, this is the number of trials, and this is the probability. This is X. It is a success. It represents the success, and this is the probability of success, and this is the probability of failure, 1 minus p. This is the probability of failure of any one trial, and this is the probability of success. This is the probability of success. Okay, so it can be written n by x. It can be written factorial n, factorial x, n minus x factorial. Okay. In the experiment of taking 3 shots at the target, this is an example. With this example, you can understand it very well what is the binomial distribution. In the experiment of taking 3 shots at the target, what is the probability of hits on all 3 shots? Hits on exactly 2 shots? So there is 2 questions. One is, what is the probability of hits on all 3 shots? And what is the probability of for hits exactly two shots? Probability of hitting the target is 0.87. It is given. So as far as our formula is known, this is the formula, this is the function, this is the function of the probability of success. Okay, this is the probability of success, this is the probability of success function. And n what is the n? N is the number of trials. So n is the number of trials here. Number of trials is 3. And x is the success, number of success, 3. And probability of success, probability of hitting the target is 0.80. So 0.80 to the power 3. 1 minus 0.80, this is the probability of failure. Its power is 3 minus 3. N is 3, x is 3, so 3 minus 3. Okay, so the probability of success hitting, probability of success hitting on all the shots is factorial 3, factorial 3, factorial 3 minus 3. And with a simple mathematical steps, we can find the value of the probability for hits on all three trials on all three shots is 0.512. Is 0.512. So this is the probability. This is the probability. This is the probability for hits on all three shots. And now the exact two shots, hitting on exactly two shots. So F2, 3 is the total number of trials, and 2 is the success. So probability, it is probability for failure, and in this way, and 3 is the total number, and S is the success number. So after simple steps, this is factorial 3, this is factorial 2, this is factorial 3 minus 2. After simple steps, we get this amount, 0.384. 0.384. So x is the number of success. So 3 here, its probability is 0.512, and 2 is the number of success. So 0.384 is the probability. Okay. Now we present this in a two-dimensional plot. Okay. Along the vertical axis, we measure the probability, and along the horizontal axis, we measure the number of hits. So when there is exactly two shots, that hit the target is 0.384, and we can present it in this. This is near about, this is the 0.38. Okay, and when all three shots hit, hit the target, then the probability is 0.51. So probability is 0.51. This line. So this is the pictorial presentation of the binomial probability distribution. Okay. So now the Poisson probability distribution. What is the Poisson probability distribution? The distribution deals with the number of occurrences over a specified interval of time or space. For example, the random variable of interest might be the number of arrivals at a car wash in 1 hour, or the number of leaks in 10 miles of pipeline. The number of occurrences will follow the Poisson probability function if it holds following two assumptions. The assumptions are: the probability of occurrences is the same for any two intervals of equal length. Between intervals, occurrence or non-occurrence is independent. Okay, between intervals, occurrence or non-occurrence is independent. So there are two assumptions. One is the probability of occurrences is the same for any two intervals of equal length. Now the Poisson probability function. Look at this Poisson probability function. Here fx represents the probability. Here fx represents the probability of x occurrences in an interval. X occurrences in an interval. And mu is the average number of occurrences in an interval. Mu is the average number of occurrences in an interval. And x is the number of occurrences. And x is the number of occurrences. And E has a value that is the 2.71828. Okay, this is the Poisson probability function. Now, here is an example. The average number of cars arriving in a 5 minutes period is 10. That is, here mu is 10. If you consider the formula, then mu is 10 here, the average number is 10. And exactly 5 cars arrived in 5 minute periods. So x is 5 here. Clear? Then find out the probability of exactly 5 arrivals in 5 minutes. So we have to find out the probability of 5. Probability of 5 arrivals. We have to find out. So this is the formula. This is the formula. This is the Poisson probability function. This is the Poisson probability function. And here mu is 10, x is 5, and E is 2.71828. So putting this value, we get this, and after simple steps, you can do it and find the value is 0.0378. Okay, this is the probability of exactly 5 arrivals in 5 minutes. Now, this is the pictorial presentation. Look, when the mean that is the average number of occurrences in an interval is 1, 4, and 10. So depending on the mu, we have 3 types of curves. And it should be mentioned here that the connecting lines, here is the connecting lines. Connecting lines are only guides for I. Okay, because it is the discrete probability distribution. You must remember it is a discrete probability distribution. So this connecting line only guides for I. Now, along this vertical axis we measure the probability of x, and along this horizontal axis we measure the x. X is the integer. X is the integer value. So now, when mu is 1, then the curve shows like this. Okay, this is the Poisson distribution curve when mu is 1. When mu is 4, then it is this dotted line represents the Poisson distribution. Okay, and when mu is 10, then this dotted line represents the Poisson distribution curve. So I hope that you have understood the discrete probability distributions, and in this lecture I have told about the uniform probability distribution, Bernoulli probability distribution, binomial probability distribution, and Poisson probability distribution. So I hope you have enjoyed this lecture, and in the second part, I will discuss about the continuous probability distribution. Thank you for enjoying this lecture.